Okay, this is a warm-up that I did in class, and I kind of want to go through this with you. And it's basically short story is that I have an arrow that's shot in the air. According to this formula, h of t equals negative 5t squared plus 30t plus 10. And I've labeled everything. The height is in feet, and the time is in seconds. So I did a little quick sketch over here, and there's a couple things I want you to notice that I did. One is, notice on this one, I started at a 10. The reason being is that if I were to put a 0 in for the time, like when I first started, I'd get a 10. So this kind of makes sense. So I shot the arrow at 10, it's going to come up and come down. And then I put it in my calculator to actually make sure that I did everything right. So I put it in here, and then I found these. So I actually graphed this. So I'm going to bring it up. And I found the max at 3:55, and then I saw it hit the ground at 6.32 seconds. So I encourage you to do that before you do it so that you know that your answer is correct. So what do I always ask you in these questions? And this is a good practice for quizzes, is the first thing I always ask is when, let me erase this again, when is the max height? And notice I'm saying the word when, so I am looking for time. So when is the maximum height? Okay, so anytime I ask you that, you're going to use your axis of symmetry. Now in this case, I always say it's x equals negative b over 2a, but as you can see, my x-axis is time, so I'm going to say time equals negative b over 2a, and as you can see above here, I labeled a, b, and c, so I've got negative b, which is negative 30, over 2 times negative 10, I get 3, and it's seconds. And I'm happy about that because I already found the point 355. What do I ask next? Well, I always ask you, how high did it actually go? Or low, but in this case, it's how high. And the only way to find that right now is I'm actually going to plug the 3 seconds into my formula because that's the time. And when I plug it into my formula, here, just the way it is, then I can find how high it actually went. And when I plug that in my calculator, I get 55 feet, and I'm happy about that because, again, that's the point I found, right? The third thing I always ask is, when does it hit the ground? Okay, so I'm going to say when, again, I'm looking for time, when does your arrow hit the ground or strike the ground, whatever. And again, if you remember, that means my height is 0, so I'm going to just take my formula here and plug it and make it equal to 0. Now I do know that it's 6.32, so I know it's not pretty. So I'm going to plug this in the quadratic formula. But as I look at these, all of these can be divided by 5. So I'm going to take out negative 5 just to make it a little bit easier. When I do, that changes all the signs. And 30 divided by negative 5 is negative 6t. 10 divided by negative 5 is negative 2, and it's equal to 0. And now this just makes it a lot easier when I stack and rack. A is 1, B is negative 6, extend the page here, C is negative 2, and when I do my D, which is B squared, 36. Now I want you to be careful, because if you have a negative there, you have to put it in parentheses to square it, or square it in your head. That's 36 minus 4 times 1 times negative 2, and I get a 44. So I'm going to sing my little song here because I have to do the quadratic formula. So I'm going to do the time equals negative b, so 6 plus or minus square root b squared minus 4ac, 44, all over 2a. And then I'm just going to split it up, my plus and minus, and put it in my calculator. Now, if it's something like this, you do not need to simplify the radical. Just tell me what this would be. And this comes out 6.31662, I believe. So this is basically 6.32. It hits the ground seconds. And this one, when I do the negative, I get negative 0.3166, which I'm going to reject, not because it's necessarily negative, but in my picture, if you'll look right up here, that would be on this side. And remember, your calculator has no idea that you're talking about an arrow in the air. So I'm going to reject it because it's not, doesn't make sense, because that would be negative time. Now, the next thing I'm going to show you is wicked cool. All right, so I'm going to do just a little line here, a little wiggly line, is I'm going to show you how the vertex formula, or completing the square, can get the same information kind of in one step. So I'm just going to do A and B and show you how that would work. So I'm going to do my vertex formula by completing the square. All right, so let's do that. You've been doing this for algebraically for me, but now we're going to actually use it in the word problem. So now I have h of t equals negative 5t squared plus 30t plus 10. Okay, now I'm going to start completing the square. So the first thing I do always is make sure there's just a 1 in front of the t squared. So I'm going to factor out negative 5, which kind of already did this. So that changes all the signs. It's t squared minus 6t plus 2. Okay, now that I have a 1 in front of the t squared, I can go now and force this in. So the negative 5 is going to hang out while I do this bracket and actually complete the square. So I'm going to force it to be a perfect square trinomial. So if I look at this, I write the variable there, same size, half the middle. Then I say, oh, what did I add that wasn't there before? That's the negative 3 squared, which is a 9. So I'm going to subtract it. And then I'm going to bring down, oh, this actually changed to a minus 2, sorry. That I'm glad I caught. So I hope you caught that. So that's a minus 2. So that's going to bring that down to make that a minus 11. So now I do my bracket here and say, all right, h of t is negative 5, the bracket, t minus 3 squared minus 11. Now I'm going to distribute the negative 5. And remember, when you distribute it, you just put it right in front of the parentheses. You don't change anything. So it's negative 5 t minus 3 squared. So that's the first term. And then negative 5 times a negative 11 is a plus 55. So if I'm doing the vertex, this is so cool. The vertex, remember, is opposite the sign in the parentheses is 3, and it's 55. And I'm like so excited because that's what we found the first time. But remember, we did the axis of symmetry for the 3, and then we threw it in to find the 55. So that helps you in one step, and that's my axis of symmetry. In one step, say, oh, at 3 seconds, my arrow was 55 feet in the air, because that's what our whole problem was. I think that is so cool. So I wanted to share that with you because I did that in class. So that's the end of this video.